What is going on, guys? Welcome to this Python tutorial series for data science. In today's video, we're going to talk about statistical functions with pandas and data frames. So let us get into the code. So in this video, we're going to continue to work with the data frame that we know from the last video or that we used in the last video. And we're particularly going to focus on age and height because they're numerical values or numerical columns. So we can apply all these statistical and aggregate functions on these columns. And one of the most basic aggregate functions is the count function. So I can just go ahead and say df, or actually print df.count, and then I would get the amount of elements per column. So I would get, I have 4 names, 4 ages, 4 heights, 4 genders. And as you can see, it does not return 16 to me because I don't ask how many elements are in the whole data frame. I ask, or actually I do ask that, but it gives me the result per column. So it says we have four elements in each column and we have 4 columns, so we have 16 elements. Of course, what I can do is I can just specify the particular column I'm interested in. So I can say dfh.count, and this would give me the amount of ages, which is of course just 4. So this is an integer value. Now, very basic function, but we have a lot more functions that we can talk about. For example, the sum function. The sum function just sums up all the individual elements to one sum. So I can just go ahead and say dfh.sum, and the result will be 177. Now, the funny thing is that I can also go ahead and sum up the name column, but of course, in this case, it will just uh, join the strings together. So it would just say Anna, Bob, John, Mike, and this would be the sum of the names. And of course, I can also just go ahead and say df.sum in general and sum up all the individual columns again. And this would give me a result like that. So I can do the same thing with the product. So I can just go ahead and say dfh.prod, and this would give me the product of the column. So it would multiply all the ages together. And this would give me, of course, a way bigger number. I think this 2,351,842 would be all the ages multiplied together. Now, these are not very statistical values, so let us get a little bit into the statistics. For example, let's pick the height column and say I want to have the mean height. So I want to know on average how high is a student. So df.height, and now I want to get the mean value. And this would give me, of course, just the average height of the students or the person. Actually, it's not a student. And the average height is 177.5. So basically adding up these values and then dividing them by 4. This would give me the mean value. Now, sometimes I'm not interested in the mean value, but I'm interested in the median. So in the value that's right in the center. So in this case, I have 4 elements, so it would just take the average of the mid 2 elements or the center 2 elements. But the median is basically useful when we have a lot of outliers. So if I have like most of my heights around 150, for example, but then I have someone who's like 3 meters or 300 centimeters tall. Of course, this is not something that you'll encounter in reality, but just in theory, it would, of course, change the mean, but the median would be still the same. So the median is 179. Of course, in this case, it doesn't make a lot of sense to take any of these values because we only have 4 values. But if you're interested in a median value, which is the value in the center when the list is sorted, you can use this function. So if I have, for example, I don't know, 5, 6, 7, 8, 9, 9, 10, and then I have like 500, this would of course produce some problems when I take the mean value because of this 500 outlier here, it would give me a very high mean value. But if I take the median, which is the center value, and I think this should be 8 or 9 or both of them, actually both of them, it would give me 8.5, which is a realistic value. So this is how you use the median function. Now, another function would be the mode. In this case, again, the mode doesn't make a lot of sense because the mode, what it does is it gives me the value that occurs the most often. So in this case, I have different values, of course. So I get all 4 of them. But if I have 1,000 values, for example, and the number 170 is the number that occurs most often, it would return this number as a mode. So let me again show this in a comment. If I have the values 1, 2, 3, 4, 5, 6, 7, 8, 8, 8, 8, 9, 9, 10, 11, it would give me a mode of 8. The next one would be 9, and then we would have just one of each. So this is the mode function, also very statistical, very important statistical metric or value. Now, another value that's interesting is the standard deviation. So how much on average does one value deviate from the mean, from the average? So it's the STD function. And for example, if I have the values, I don't know, uh, or let's say I have a mean of 10, so I have some values and the average value is 10. Now I want to know on average the values, how much do they deviate from 10? So for example, if I have 12 and 8, the standard deviation would be 2 because I'm basically deviating 2 from the mean on average. And this is what we calculate with the standard deviation. So in this case, the standard deviation of the height would be 9.46 centimeters. So on average, when we take the average value, I don't know what that was, I forgot it, df dot height dot mean. So I have a mean of 177.5, and on average the heights deviate 9 point almost 5 centimeters from that, because of course we have minus 9 plus 9, as you can see. This is the average deviation basically. Now another value or another aggregate function that we can look at, very simple one, is not mix, min and max. So basically the lowest height or the minimum height and the maximum height. So just the highest and the lowest value of this column. Now, one last function that I want to talk about is the describe function, because this function gives you a summary of the data frame or a summary of the column. So if I go ahead and say print df and then height dot describe, what happens is I get a summary of the statistical values. So I see, okay, we have 4 elements in here. The mean is 177.5. The standard deviation is 9.469248. The minimum value is that, and the maximum value is that. And here we get, I think, I'm not sure, don't take my word for that, but I think these are um, these values are basically telling you, okay, 25% of the values are below that, 50% of the values are below that, and 75% of the values are below that value. So basically percentiles, I think that's the term for that, but basically just telling you how the values are distributed. And this is a very useful function to describe a column. I think we should also be able to call it on the data frame, but I'm not sure about that. Yeah, of course. So we have age and height. As you can see, it only takes the numerical values and then gives you the summary of the statistics here. So that's basically it. So these are the basics of statistical functions with pandas and data frames. I hope you enjoyed this video. I hope you learned something. If so, hit the like button to support this channel. And of course, feel free to ask questions and give feedback in the comment section down below. Also, don't forget to subscribe to this channel if you want to see more. And thank you very much for watching. See you in the next video. Bye.